Okay, so example 1 for the line integral, if you are given a vector field. So the vector field given is y square minus z square and then 2yz minus x square. Okay, so f dot dr. So what is dr? dr is so maybe your r is t square to t and t. Okay, so dr mean you have to differentiate to t to 1 dt. So when you have f dot dr, so meaning that you have to multiply the component x with the x, then component y with the y, plus the component z with the z. So then you can have 2t y square minus z square plus 2yz minus x square. Okay, and you have dt. So meaning that your dt here becomes your order of integration later on, right? Then you have to convert the x, y, z in terms of t as well. So 2t, so y squared minus x squared. So y square is 4t square minus t square plus 4, y is 2t and z is t minus x4. So x minus x squared, so t squared square, so minus t4 dt. So then we expand that, you have 8 t cubed minus 2t cubed plus 8t square minus t4 dt. So when we plug into the line integral, because we want to get the line integral f dot dr, so f dot dr is, so we got 6t cubed plus 8t square minus t4 dt. And what is the limit of t? So it is given, luckily. If not, you have to find it. So t is from 0 to 1. So now you can see that the line integral for vector field from f dot dr, it reduced to a common definite integral in terms of t. So when we integrate, you will get 6 over 4 t4 minus 8 over 3 t cubed minus 1 over 5 t5 0 to 1, 6 over 4, 8 over 3 minus 1 over 5. And you will get this one. Okay, so that is one of the example. So now we look at the next example. So example 2. So now let's look at the example. Your f is given by x plus y, y minus x, only I and t. So you have to compute the line integral for the vector field where your curve is the path along the parabolic. Okay, so x equal to y square. What is the graph of? Now you have y and your x here. So it looks like that is the curve, isn't it? Okay, but you have to evaluate from the point of 1, 1 to 4, 2. So let's say the point of 1, 1 is here, and this one is when it is x equal to 1, y is 1. So when x is 4, sorry, if your y is 2, y to x is 4. This one, this is 2. So that is only the curve that we are interested on. That meaning that we have to erase other curve. So we don't want this. Also we don't want this. So that is the curve path along the parabolic curve from the point 1, 1. So we have the point 1, 1 to 4, 2. So that is your curve. Okay, so now you only have x and y. There is no z. So now we want to obtain the f dot dr. F dot dr. So what is dr? Dr is dx dy. It is a vector, okay? So now dr is dx dy. Okay, but at the moment your function is not in terms of t, so you can just leave your dr just dx and dy. Okay, so now we multiply the component x with the component x, so x plus y dx plus y minus x dy. Okay, so you can, as we done in the scalar form, if you only have x and y, so there is a possibility that you can evaluate your line integral without transforming your expression here in terms of t. You can transform into only x or in terms of only y. So it looks like it's more easier if you replace the x by the y, because when you can see the x, you have the y squared immediately, right? Meaning that rather than if you replace the y, you have to deal with the plus minus square root. So it's more tedious. So now we have to convert everything in terms of y. Okay, so what we can do is, when you can see x, so you will have y square plus y. And what is the x? So we will look at that later. And then y minus y square dy. So now how can we have dx? So you can get the dx in terms of dy using your curve function. So what we can do is we can differentiate implicitly where you have y square x. Okay, so you can have you want to have the dx. So 2y dy, and this is dx. So we can say that dx is 2y dy. And when we expand, so you have the dy, we have the dy, meaning that you can combine them together. So you have 2y cubed plus 2y square plus y minus y square dy. And when we simplify, then we integrate with respect to y. We replace the limit of y from 1 to 2, and we obtain that the answer is 34/3. Okay, so this one, if you use you transform in terms of y. Okay, and also actually you can obtain the f dot dr. So from this step, where your f dot dr over the curve C is given by the x plus y dx plus y minus x dy. Okay, then you can convert everything in terms of t, and you have instead of you have dx and dy, you have dt. So but for this you have to have the r function in terms of t. Okay, the vector function of the curve, but it is not so complicated. So you know that your curve is this one part of the quadratic, where it's coming from this equation. So I'm sure that you have no problem with that. So for this, meaning that you can assume to get the vector x in terms of t, since x is equal to y squared, so we can let the simplest parametric equation that we can have, we set y equal to t, so that your x is t square. So then you can have your r, your vector function of this curve is given by t square t. Okay, so when you have the dr, which means that you have to differentiate the t squared become 2t, and t is 1, you have to put dt at the back. And then you just have the f dot dr, meaning that you have to multiply your f. So your f is x plus y. So in this case, now your integration becomes the f dot dr. So x plus y multiplied by 2t plus y minus x multiplied by the component of the dx here. Sorry, dy. So dy is 1, and then you have to put the dt. Okay, but then you have to convert x and y in terms of t using your parametric equation here. So I'm not going to complete that. Okay, so how about the limit of t? Because you need to obtain the limit, you have to integrate with respect to t. Okay, maybe I can give you the result after you substitute. So your expression will become 2t cubed plus t square plus t dt. So you need the limit of t. So you have to show this, okay, after you substitute x and y, and you simplify, and you will get this form of expression. Okay, but you need to obtain the limit of t. So now, based on your curve and your point that we have, so for this, we know that the value of the parametric equation of x and y we already obtained that is one, right? So now you have to determine for this what is the t if you want to have x1 and y1. So you have to set t equal to 1, right? T equal to 1. And for this, what is the value of t, so that your y is 2, x4. So you have to set t equal to 2. So now we already obtained the limit of t is from 1 to 2. 1 to 2. And you will get the similar answer. So please show it. Okay.